All right, welcome back to another episode of Science with Surback. Today, what we're going to be talking about is section 6.1, which deals with the development of the modern periodic table. In section 6.1, our objective is to trace the development and identify key features of the periodic table. So we start out here with why there was a need for the periodic table. So in the 1700s, you have to remember there are many experiments being conducted. There are many new elements being discovered. And so the Frenchman, Lavoisier here, he contained a list of 23 elements. Now, a list of 23 elements and their properties is pretty easy to flip through. But as time progressed, that list became more extensive. So as time goes on here, in the 17 into the 1800s, we have a major thing happen. One, we get electricity. Two, we get the Industrial Revolution, which means we get better technology. Better technology leads to more experiments that can be conducted at a higher detailed level. Okay, so what happened here is this. We get a lot of specialized tools. One of which is called the spectrometer, which is used to identify light by using that light and wavelength and frequency we briefly discussed in chapter 5. And so by the end of the 1800s, there's almost 70 known elements. So now we've tripled our amount of elements, and no longer is it easy to flip through a stack of elements and their properties. We need a way to organize that information. So what we do here, what happens is this. The scientists say, hey, there is a lot of information. It's like flipping through a manual. It's a very tedious process. We need a quick way to have a snapshot of what is happening in those properties that are used for many things here. And so what they said is, okay, there's some kind of relationship between the mass and the properties we see in the elements. And so mass, for the most part, if we look on the periodic table that we use today, is different, almost different for each and every element. And so that's where they really started off trying to place the elements in some type of pattern. So John Newlands, he's the first scientist to organize what happens here in the periodic, or put the elements in some type of pattern. And so what he did here is he put the elements in increasing atomic mass. And what he noticed is that every so often, or periodically, patterns would show up. Okay? And so this periodic relationship became known as the Law of Octaves, because what he noticed, for the most part, every 8 elements that were known at the time seemed to have this repeating pattern in terms of chemical behavior. However, this law, which really shouldn't have been a law at all, did not work for all the known elements. So they have a system now to help organize the elements here in increasing atomic mass, but it doesn't work, or doesn't hold true for each and every element. All right, so now comes the real big revolution here in what we know the periodic table. So with the periodic table, we have this. We have our big players of our game here. And so what happened was, yes, there was still a connection between atomic mass and that elemental properties. And so Dmitri Mendeleev, what he did here was really instrumental. He said, yes, there is that periodic pattern that John Newlands first discovered, but he said, we don't know all the details yet of this particular table. We need to leave gaps. He left spaces, which is monumental. He left spaces and said, hey, based on the properties, there isn't an element we know, but there should be an element there. So what happened here? by leaving spaces, Mendeleev created the basis for the modern periodic table of the elements. There was one thing that had to be changed, and we'll talk about that here in just a second. But what happened here was, again, Mendeleev left spaces, left those blanks that were undiscovered elements. And those blanks eventually became discovered elements with properties very, very closely predicted by Mendeleev. A very monumental, very instrumental portion here to modernize chemistry and modernize what we knew about our matter. So our last arrangement here comes from Henry Moseley, and Moseley, what he did is he said, okay, we almost got it right, but some of the chemical properties do not hold true. And so what he did is he said, okay, well, if we, instead of place the elements in increasing atomic mass, let's place them by increasing atomic number. And remember that atomic number is equal to the number of protons in the nucleus of our atoms. So what happens here is this. Because he replaces this with our atomic number, or puts the elements in increasing atomic number, we get the periodic law, which is just a periodic repetition of chemical and physical properties of the elements. Now, this law held true, whereas the law of octaves sometimes broke down. Periodic law, because we have the elements arranged in the modern periodic table, we are able to identify some different areas here. All right. So let's go ahead. Let's orientate ourselves to the periodic table. So with our periodic table, and we're going to use the periodic table that is found on the next sheet here, and I have a blank copies, and we're going to talk about each and every one of our areas and each of our particular groups. So with our groups here, we have our up and down columns as our groups. So if I grab a periodic table here, our up and down columns here, these guys right here, these are known as the groups. And so I'm just going to label this, and I'd like you to label it as well as our groups in our periodic table. Now again, groups are your up and down columns. Periods are, on the other hand, are your left and right rows. So again, we get our periods as our left and right rows. Okay, and so now we have a basic orientation, and this orientation will be even more expanded here, but we can break the periodic table and we can have some essential information from that periodic table. Now, each periodic table is just a little bit different, but you're going to find the same information. So you're going to find the atomic number, which is that whole number equal to the number of protons in the nucleus. You're going to find the elemental symbol, which is a 1 or 2 letter way to represent the element we're discussing. We're going to find the average atomic mass, and you're going to find the element name spelled out on the periodic table. So again, keep this periodic table handy because we are going to be utilizing it throughout this particular lesson and section. Okay, so let's go ahead, let's get down to business here, and let's talk about the main categories of the periodic table. Okay, so the main categories of the periodic table are metals, nonmetals, and metalloids. Now, metals are going to be found on the left-hand side of the periodic table. And you can see that their general properties, they're good conductors, they're malleable, which means they can be beat into or pounded into sheets, and they're ductile, or they can be drawn into wires. Now, what we want to do is we want to go one step further, and we want to identify specific areas. But before we do that, what I want to do is I want to divide our periodic table into certain areas, okay? So let me get out my periodic table here, and let's identify these three main areas on our periodic table. So the first thing that we want to do when we divide our periodic table or show the division of our periodic table is we want to identify the metalloids. So the metalloids here are going to be defined as the stair-step line that divides the periodic table from the metals and the non-metals here. So we'll go down one more row. And so each thing that I box in here, and I'll eventually highlight in red, these are considered our metalloids. And it's very significant that we identify the metalloids because the left-hand side will identify the generic term metals, and the right-hand side will identify our non-metals. So again, I'm just going to highlight, or I'm going to color these in, and I would suggest you get a set of either colored pencils or something to identify each of the different areas of the periodic table. And so what I want you to do here is I want you to realize this. This right here, our metalloids, are the major division, or is the major division, of the periodic tables from metals and nonmetals. So up here, up the top here, I'm going to use my colored pencil, the orange-red here color, and these represent these 6 metalloids. Now, with this being said here, our division of the periodic table is this. Anything to the left of the metalloids is going to be considered a metal. So again, if we go anything to the left of the periodic table, these are considered metals, okay? Anything to the right of the stair-step line is going to be considered non-metals. So those are your 2 major divisions. Now we want to go further and talk about the other parts of the periodic table. So again, we went over our metals, non-metals, and metalloids. We are going to get in the details here of some specific metals. Now, there is one exception to our metals here on the left-hand side. Hydrogen is not a metal, okay? It is actually a non-metal. All right, so keep this periodic table handy. We're going to utilize it here shortly. So we start out here with alkali earth metals, okay? So alkali earth metals are considered group 1 elements with the exception of hydrogen, okay? So let's identify that, and we're going to use a different color to identify those alkali metals. So our group 1 and I'm going to use green, our group 1 elements, lithium all the way down to francium, these elements are going to be considered to be alkali metals. So again, all I'm going to do is highlight these in green so we can identify a different area of the periodic table. So again, what I have here in this green colors, are alkali metals. Now, I want to point this out. hydrogen is a non-metal. So be aware of that. Now, the next group over here is group number 2, and the specific group name that we have for group number 2 is the alkaline earth metals. Okay, so the alkaline earth metals are group 2, all group 2 elements, and I am going to highlight this here with a pink colored pencil. So right here in pink, I am going to highlight all group 2 elements, and group 2 elements are known as alkaline earth metals. So just down below here, I'm going to make my map key here, and our pink elements are known as alkaline earth metals. All right, so now moving on here, we have 2 important categories. Category number 1, which I'm going to highlight here in yellow, are these transition elements, which are the elements in that D block set of electrons. So in yellow, I'm going to identify the transition metals. So again, in yellow, I'm going to identify the transition metals here. And these, remember, are the D block set of electrons. So again, everything here that I am highlighting in yellow is considered to be the D block set of electrons. They're also called the transition metals. So in yellow here, and yellow's hard to see, so I'm going to write this in pencil, but the yellow elements here are transition metals. Okay, our other item here, we want to label the inner transition metals, which are down below the transition metals. So let me show you here. I'm going to highlight this in light blue. And so down here, what we call the lanthanide and actinide series, these are the inner transition metals. And again, I'm just going to shade these in quickly. These elements that I'm shading in here blue is the inner transition metals. So again, in blue here is the inner transition metals, and I'm going to label this down here. So blue is our inner transition metals. All right, so we're going to keep this periodic table handy, but we're going to move on here to our distinct categories or areas for nonmetals. All right, so I'm going to toss this aside. We're going to use it here in a second, but our nonmetals consist of 2 significant groups. The first group is known as the halogens. And this consists of all group 17 elements, okay? So with this, what I am going to do here, I am going to color this in a different color. I'm going to use orange to identify my halogens. So I'm going to grab my periodic table. My halogens here are going to consist of element fluorine all the way down to tennessine, and these are going to be considered our halogens, okay? So in orange here, in orange, these are known as your halogens, okay? All right, so now the last category that we are really going to concentrate here is the noble gases, okay? So the noble gases, what I am going to do here in magenta, I'm going to label the noble gases, which are group 18 elements, okay? So group 18 elements highlighted in this nice, pretty magenta color. These are known as your noble gases. Okay, so again, in pink here, these are known as your noble gases. All right, so there are two areas that we need to talk about here, and I'm going to highlight them very, very quickly. In gray, I'm going to highlight these elements here, and these right here are considered your other non-metals. So again, the elements here that I'm highlighting in gray are considered your other non-metals, okay? So I'm going to label this up top here in gray. These are your other non-metals, and we also need to throw in hydrogen to this category here. So we're going to throw in hydrogen to our other non-metal area, okay? Because it is considered a non-metal, so don't forget about hydrogen. Our last thing here, our last thing that we are going to label, and I'm going to label here in this teal color, is going to be our other metals, okay? So these other metals are going to be what I have labeled in teal. Now, as we finish up highlighting these other metals, I want to emphasize this point here, okay? Our metals differ from our nonmetals because our nonmetals are typically gases and they're poor conductors of electricity. Our noble gases are very, very unreactive, unlike the halogens, which are very reactive. All right, so there are the distinct areas of our periodic table. I know it looks kind of messy, but those are the specific areas of the periodic table. All right, so now we only have one more slide of notes left, and that is talking about the other, or the metalloids, which we've already discussed a little bit here. So the metalloids have properties of both metal and nonmetals. That's why they're called metalloids. Sometimes they're called semimetals or semiconductors. And they form that stair-step line of 6 elements. So the stair-step line, again, we initially labeled that here when we started coloring in the periodic table. And this stair-step line represents our metalloids. So those are our metalloids and those are our properties. All right, so we've gone through a lot. We've identified why or where the periodic table came from. And we've also, more importantly, identified where each of those sections are in the periodic table. I hope you have enjoyed this particular episode, and as always, if you have not done so, make sure you subscribe.